All right, I think everything's recording.
Cool.
We never know.
Yeah, no, that's good.
That's how we do things here at EmberMap. We like to wing things.
Absolutely. Improvisation, jazz style.
You know, there's not enough of that in programming. I really feel like we should deploy more improvised code to production. Right? Just like I was feeling this, I was inspired, wrote some lists here, pushed it up to my server. You know, it doesn't work out, but...
It's not a terrible analogy. Like, it's not as simple as like, oh, yeah, let's just deploy more. I know that's like the joke version, right? But there is that same creativity and improvisation going on in code. It's just before you can unlock that level, you have to already be like, you know, there's this balance, right? If you're actually good enough that the code you're shipping is good, you do start to unlock that creativity, right?
You have to be good with the tools.
Yeah, you have to know like a jazz musician, right? You can't really just go crazy improvising until you know what rules you're breaking and you're a master of your instrument.
That's true.
Yeah.
You know the Brett Victor talks. You know Brett Victor?
Yeah.
He talks a lot about that, and he has some funny saying where he's like, the only people who can code today are people who have happen to have a knack for manipulating like symbols.
Yes.
In a weird way.
Uh-huh.
And there's lots of people who maybe could contribute or design systems similar to the ones we write with programming languages, who are better with their hands or with other visual tools, but now they're limited.
Correct. Yes. We are still fundamentally limited by our input-output technologies, I think, at this point, right? So it's like something like pervasive AR is going to let people harness a big other chunk of their brains for understanding what's going on in a system. If it's still really hard to go beyond the screen, beyond purely visual, and do those other things. And I think it's mostly a hardware problem. Like, there are some things you can do, and he's demoed stuff, but none of it ever goes beyond demo. I think programming is fundamentally symbolic, or maybe symbolic's the wrong word, but language oriented. Like, because computer languages really are languages, like they're tools for thinking. And so, if anything, I think the harnessing a larger set of people to do programming, it probably harnesses more of our language instinct than our like spatial, physical instinct. I mean, some of that matters. Sometimes you're solving problems that are very spatial, very visual, and having tools that support that, where you can actually see what's going on, matter a great deal. But a lot of what we do in programming is much more. It is symbolic. It is linguistic. And what's weird about it is more the level of precision required in the language than the fact that it's linguistic. Like humans, a much broader set of people have great linguistic capability than can program, because it's just a weird level of precision that requires. Right. So like conversational programming where you're having
more forgiving.
Yeah. I would see that like accessible programming that actually does the programming part. Like, there's kind of low code approaches to things, which really comes down to having a great toolbox of primitives that already exist that you can plug together, like Legos. Like, in practical terms, that's the only way we actually build software faster or let more people do it. But of course, that means somebody's got to be making the Legos. There's always that problem. To do that piece and get more people doing that, I think I would envision it going toward conversational, right? Like being able to have a two-way communication with the machine where you'd just be like, I want it to do this. And they're like, well, here's what that looks like. I'm going to show you a dozen examples of what you just told me to do. And they're like, no, I didn't mean that. I meant that.
Interesting. Right. Is that kind of like the audio interface or something like a Siri or Alexa where...
it would use some of that.
You have some forgiveness in the commands as opposed to like a syntax error.
Yeah, no, it would definitely need some kind of... So a bit of natural language... you would need a bit of natural language understanding to get over the surface level what's hard about programming. Beginners when beginners encounter programming, they think that is what's hard about programming, right? It's like remembering all the semicolons and getting all the syntax right. And once you're experienced, that's not actually what's hard about it. That was just this annoying accidental complexity you had to get through.
It's JavaScript state management is what's hard about programming. That is the thing.
I suppose so. State management is hard, but people overestimate how much state they have or need. Yes.
That's why it's hard.
Yeah. Well, true. Yeah.
Interesting. The only other thing I'll say about this is, Brett Victor talking about mathematics, which originally struck me as even more kind of in this domain that you're talking about, is more symbolic, more abstract. But then he was talking about some Calc 3 stuff and what really cemented like Fourier sequences for him, or some of the trigonometric geometry stuff.
Yes.
And it's like once you see it is actually when you understand the formula. And so
Yes.
there's still part of me that thinks like, I'm not sure that
There's
maybe the
yes,
future
no,
programming
there's
looks visual and manipulative.
some stuff is
and
very
constrained.
visual.
Yeah.
Absolutely. I mean, for me, learning trigonometry was just the natural fallout of wanting to be able to make little things shoot at each other on a screen, right? Like you need that.
Right.
And once you've done that once, you deeply just get why you'd have it. And I do think that, I mean, maybe this is the bubble I travel in, but I think that mathematical visualization as a way to teach has gotten dramatically better. Like maybe most kids in school are still not getting a chance to see an animation of a like a Fourier series of spinning circles that draws out a function, but like they should, and more are finally. Like there's just, you can't stop it. There's so much good content out there, like even just random YouTube videos or that, there's a natural inclination that if you're trying to teach this stuff, you're just some teacher and you've got the tools that you were given, but it's kind of hard not to notice now that there's all these other tools out there that are just, even if it's like a 30-second clip, can make a real difference when you can visualize these things.
Yep.
Yeah. Have you ever seen, it's like 3 blue, 1 brown on YouTube?
I don't know that one. No.
He does like all these math visualizations, and they like click when you.
I drive my wife crazy because if I'm sitting like next to her and I'm like flipping through YouTube, it's all math videos and things like that. She's like, she'll hear
Vida Hart, or what's her name? Vi Hart. She makes these really cool videos.
Oh,
as
yeah?
well.
It's a great one on
Like
like
the
Cantor.
fractals.
Oh, yeah.
Cantor,
Exactly.
Yeah, no, there's a stand-up maths guy out of the UK. I like his stuff. He's very amusing. And the mathology videos, that he's like super dry math professor with an extremely geeky sense of humor. And when his intro music plays, my wife was just like, another one of those.
So we were at the Cauldron for dinner last night, which is possibly the nerdiest bar/restaurant in all of Manhattan.
It's a Lord of the Rings.
It's not even just Lord of the Rings. It's like generic fantasy, sci-fi. Like you can get like Garv got a cocktail that like you pour this potion in it, like bubbles over.
Yeah.
And Ed and who else got the
Jen had one, the flaming
Jen had
cocktail.
one, the flaming cocktail.
Yeah.
Do you actually light it on fire?
It comes out on
They
fire,
do.
yeah.
But we were having this debate at the beginning of the meal, who's like the nerdiest, because like programmers are already pretty nerdy, but this was an exceptionally nerdy table. And Jen wore an elvish necklace to her wedding.
Yeah.
And Ed, what was the nerdiest thing that we were saying?
I mean, you were asking if I could speak any Elvish. I was like,
oh, right.
I understand a
speak
little. I can't really speak it, but I understand a few words.
So
Yeah.
this is a pretty epic battle going on right now in the Cauldron. And I
Yeah.
was just like, yep, I'm proud to be here.
I could probably tell you the names of like all the horses in Lord of the Rings.
Wow.
But
Like not just Shadowfax.
No,
like,
no.
Many of them.
Oh yeah. Hasafel and Asfaloth. Oh yeah.
Oh, that's good. That's good.
Yeah. I basically started running out of names because, like, I don't know, naming servers over the years, they were always like a Lord of the Rings character, and I got through all of the like first class characters, and then I started getting down to the secondary characters. And now I've got ones named after like the animals now. It's like you run out of names.
That's funny. They are good names though.
Oh, totally.
Talk about language. That's okay. Anyways, so
yeah, totally. No, Tolkien would probably be interested in programming languages. He was so into languages.
Yeah. I liked what you were saying about the wanting to make things move on the screen and therefore learning about Fourier series, because it feels like that's been a lot of what your work has been. Like, how do you happen to know about writing like friction tweens and Ember animated?
Yeah,
and it's probably because you had an idea for what you wanted this div to look like when it moved across the screen.
mean, right. It's a lot of just growing intuition from experience, right? It's the stuff that is like criminally bad at the way schools teach math. They give everybody the impression that it's about getting the right answers, and video games and animation are actually like a perfect antidote to that, because it's very clear that the right answer is when it feels the way you want it to, right? Like, what's the right math to use to make a div feel realistic? It's probably not even like you could, if you want to say, okay, well, it's the right math if you actually use the same physics a real object would have, but like all of that just has judgment calls. There's no real object. It's not real, right? So it's all very subjective and creative. And to do that with math requires a totally different mindset when you approach it. It's all about knowing the feel of things, getting a sense for the aesthetics of things. And I think that's where all the fun is. And like most people only get a tiny glimpse of that with the way they're exposed to math in schools. We should be making a lot more kids make video games, I think.
Amen to that.
Yeah.
Something you said reminded me of your talk from last year, actually, which I rewatched in prep for our Ember animated training. And you were talking about how you think the way most people approach animation on the web is wrong because it's too hard. It makes it too hard for people. That was one of the points. And it also seems like a theme in some of your other work. And, even just 10 minutes ago, you were talking about the Lego blocks and the builders of those. So, yeah, that seems like maybe it's something that is like one of your values.
A theme?
And
Yeah,
probably
totally.
why you're probably in the Ember community.
Yes. No, I can summarize pretty succinctly what I see as the kind of motivating mission value in the work I try to do, which is I see the importance and power of software just taking over everything and affecting every aspect of life. And at the same time, from two directions, we fail to give people that access to most of that power. From the design of our tools side, our tools are not humanistic enough. They're not well designed enough. They're not accessible enough. We can make the tools far better, so that the affordances are just fit many more people, right? And from the other side, it's the way that we teach people to think, the way that we teach people about math, about logic, about programming is very off. And that, again, robs people the ability to take advantage of all this power that software is putting out into the world. And so that closing that gap I see as a major social problem, because when software mediates everything, if you would have no understanding of it and it's only controlled by this tiny priesthood, you don't end up with a equal or fair or egalitarian society. Or you can't have liberty, you can't have equality. You don't have any of those things if there's a tiny priesthood who controls all the software and nobody else understands software, right? So, and I don't think it comes down to delegating. Like there's certain things you just don't want to delegate if you want to have a society where everybody's participating, right? So I do want to see a world where computers are a thing that actually empowers ordinary people. That was the original vision of the PC revolution, all this stuff. If you look at when people were like first putting computers into the hands of ordinary people, that was a big deal. Up till that point, computers were a thing that only like governments and militaries and massive corporations even had, right?
I just watched Gary Bernhardt's talk on Doug Engelbert on the mother of all demos.
Yeah.
And that was all what that talk was about.
Exactly. That was the original vision, right? It was going to liberate people because ordinary people would have all this power. And it did a lot of that. It's like we definitely democratized a lot of things. Even just desktop publishing, people forget how big a deal that was, that you could now, with just a computer, you could make a publication and share it with everybody, even if that was even in print form, pre-web, that was still a big deal, like compared with what came before. And then of course the web takes that way further, right?
Right.
So a lot of the promise has happened, but there's so much more to do,
Yeah.
And there's definitely a pendulum that swings back and forth in terms of how centralized things get and how distributed things get.
Yeah.
And it's easy to get pessimistic when you see how centralized and entrenched network effects can be with some like of the Facebook of today, right? Or, but we've been there before. These things go through cycles. I think there will be another swing toward a more diverse, decentralized internet. We need to figure out how to make it happen.
Everyone writes their own blogs. I think that's the answer.
Well, I mean, kind of.
It's like kind of what everyone's been doing the last few months, right?
True.
Everyone's pulling out a Medium and
yeah.
Facebook
Well, that's
posts,
a good point.
Writing
Yeah.
Gatsby blogs. I mean,
Yeah.
that's
Yeah.
there's something there.
There's something there. I think that we have to remember, like from a design perspective, from a UI perspective, it's not like Facebook did anything super innovative. The innovative thing was the packaging that brought it all together really nicely for people who like the geeks among us were already sharing photos on the internet and already sharing posts on the internet and had a feed of all our friends because it was the RSS or whatever, right?
Mm-hmm.
But it was too hard for ordinary folks to do. Facebook packaged that up, made it easy,
Mm-hmm.
and that became the way everybody did everything.
Mm-hmm.
But now they've actually taught those patterns. Now the idea of like making a post is a thing everybody knows. So that like, there's this definitely in design, there's this interplay between you can only innovate so far because people have their understanding of how systems work, right?
Mm-hmm.
And if you try to, so once people have learned a thing, the bar gets lower for the next iteration around. Like now that
Mm-hmm.
now that everybody understands what it's like to make an Instagram post, to update a Facebook status, that does actually help like craft the next version of this, right? Like you don't have to invent the paradigm. People understand the paradigm. So the hope would be that, like, I don't know what the shape of it looks like. I don't know what's the hook that gets people to do a new thing, but the new thing will, it'll take advantage of the patterns people already know, right? Just hopefully in a way that's
more accessible to more people.
Yeah, and less, as a side effect of this centralization, we've also just got a web that's a lot more boring, right? Like it's all looks the same. You can't, there's definitely pros and cons to the fact that you can't MySpace up your Facebook page and make
Right.
it like, change the background to
Right.
flashing stars or something. But there's a lot of people who got their start in technology by just messing with stuff like that,
Yep.
right? And when you don't see that in the centralized platforms because they're trying to have a really consistently controlled experience.
Maybe that's the thing that gets the pendulum to swing back to the decentralized,
Mm-hmm.
right? Like, I want to customize stuff.
Mm-hmm.
And we see it, like you said, with blogs, we see more people moving
Yes.
off Medium and setting up their own stuff. So.
Yeah. So, you have to it has to be easy. And, but it can be. It's like this, and it's open source, we keep commoditizing all the hard parts, right? And it takes longer than people think. It always does, because like actually solid software that's really reusable that many people can use, it's harder to build than people think, especially if you come from
way harder.
Well,
Yeah.
well, it has to stand the test of time.
Yeah.
Yes, exactly.
So even if you build the perfect thing, it's worthless until it lasts for 10 years.
Yeah, exactly. And especially, this is especially acute misunderstanding in like the web app development space, because, a good thing about web development is that it's very accessible. Lots of people get into it as their first thing they do in technology. You can come from a relatively less technical role and shift into a more technical role and learn the technologies as you go. And that's great, and it's empowering, and it's a good thing. It's a good thing that JavaScript is like a language that's running on every computer already, and anybody can just pick it up and start learning it. That's really great. But it gives us this social challenge where because the set of people who are doing it is growing all the time, the average level of experience, the median level of experience is extremely low, right? Like, because no matter how fast you train up people and people grow and get more experienced,
There's a fat tail.
there's just a constant influx of newbies. And so the overall level of discourse doesn't really go beyond newbie.
Often.
It does, but there's like always that it definitely sets the tone for the whole community, right? You can only go so fast or so far. And it's not that, it's not that you can't have, it's not that you can't grow good technology. It's not that newbies can't use good technology or even see it or know it when they see it. But it's more about the questions and the framing people have when they talk about what's important in software, what's hard in software. Tends to have blind spots, right? Like there's just things that are hard that you don't realize are hard until you've gotten 4 years in on some long-lived application, right? Or until you've tried to build the distinction between an application, like if you've been building apps for a specific client or your job, that's like a very different kind of programming than making the next layer of infrastructure down. Like you'd be like, well, I've made a bunch of apps, so I know what apps need, so I'm going to build my own bundling system because I know what apps need. That's like, it's good that people make that leap. People absolutely should make that leap. I'm not discouraging anybody from trying to make infrastructure, but everybody, when they do that, underestimates the difficulty of the step function they just went up.
Mm-hmm.
Right? Like going all the way back to let's see, who wrote the Mythical Man Month?
Oh, Fred Brooks.
Right. So one of his good essays in that collection talks about the difference between like making a program that's a product and making a program that's a system. And it basically makes a two-dimensional axis out of it, where like you start with you have a program. It's basically, it works on my machine, right? And that's a certain level of effort. And we know that that's like the least effort. Is like, I just made a program. It solves my problem and it runs on my machine.
One customer.
Yeah, right. And then not even maybe customer, because it's like to go to product. Maybe yes. To go to product, it has to satisfy more than one customer, or it's got to be polished enough that other people can learn it, or it's got to work on their machine and not just my machine. So to go from program to program product adds like very significant difficulty, right? And in his very rough, and this is dating all the way back to the 80s, right? Measuring specific projects back then. So take it with a grain of salt, but he was calling it like a factor of 3 or 4x. Like after you actually completed the program, to go all the way to product was 3 or 4x more work. And then along the other dimension was a programming system, which is really when you're writing a program that's going to have to be used and interact with other programs. Mm-hmm. So something like, a framework, a web framework, a build system, a library that's going to be underneath a lot of other apps. Now you're talking about making a programming system. That was also a factor of 3 or 4x harder in terms of the time it takes to get it right. And of course, those then compose.
Right.
So that if you're making a programming system product, you're now at 9 or 12x difficulty. And if you've only ever worked on like apps that are either completely at just like program level or program product level, you can actually be extremely hard on yourself when you're like, why is this taking so long? Why is it so bad? It's like, it's actually supposed to take 10 times longer, but you don't realize.
Yeah.
Right? So we definitely see that in the web a lot because people get to start out on the easy corner. And you can do cool and interesting things on the easy corner. It's like, I can just make a web page and it works and it looks good and I can even send that to my friends. Like, that's really powerful and it's great and accessible. But then like, it's easy to not notice where the cliffs are.
Yep, totally. I mean, yeah.
You work on a lot of those, 9 to 10x
I do.
system
that's
products.
That's what I enjoy. And honestly, yes, I enjoy them, but I also sometimes just feel like I'm sucked into being in that part of the problem space, because it's just true that there's each of those.
You've been around the block.
I've been around the block. So there's only so many people who do those things. And
have you noticed anything that lets you, not pay that 9 to 10x cost, but maybe there's like a 5x jump you can make?
Sure.
Like,
I mean, well, a lot of it. I think the only that's also Fred Brooks' essay, right? It's called "There's No Silver Bullet," but in there he actually has the hint of what is the silver bullet, which is really comes down to the buzzword then was code reuse, but it's really, I would call it open sharing, or I would call it shared infrastructure, right? The only way to go faster is to have code that already works and that not only exists but exists with primitives and interfaces that you can actually understand and build upon. And when you have that, then you can go faster, right? So, for example, there's not a shortcut that would let you build a complete great application framework for the web without paying the full cost of making a full programming system. But if you were to if you were starting today and you wanted to curate an experience like that, there's an awful lot of the sub pieces that you could take that exist, right? Mm-hmm. You would be like, oh, well, I don't have to write a transpiler because Babel's good enough, and I don't need to figure out how to traverse the module graph if I plug in Webpack there, right? So it all matters. You can go faster with that. It's not that. So yes, you can go faster, but you still need to be. I think you still need the same skill set, because knowing which existing thing to use is kind of, you need to be able to judge it critically at the level of, I could have made this, but I'm not going to make it because I see that it's good enough, right? I think, and that's also why in with the median JavaScript developer being very green, decisions about what technology to choose end up being very tedious, because it is hard to pick among things that are. It's much easier to choose among technologies that you could have made yourself, but you realize it's better to share with the community, right? That's like once you're experienced, you can get to that point. You could say, I get how this works. I see why they did what they did. I can understand the trade-offs they made. Those seem like good trade-offs to me. I'm going to use that tool. But of course, a lot of the value of the tools is accruing to people who couldn't have written them in the first place, who are really then they're forced to decide on a lot less information, right? And so you definitely get more trend-driven, fad-driven. Like, and that's not to even be super critical. Like, that's just how humans have to function, right? We can't all figure out everything from first principles. We have to do what our friends are doing.
That's true everywhere.
Yes,
not just software.
Exactly. So, right. Like, you're not going to become an expert in medicine to decide what to do. You've got to like follow what seems to be the best advice and trust some expert, or ask what your friends are doing, right? And so that totally happens in software too. But it does mean that it's like it can be frustrating and tedious for the folks who do have the deeper expertise.
Who would rather build consensus around things and be able to move on to the next rung of the ladder.
Yeah, that's a good way to say it. Or even just making, having frustration over basically like the difference between something that just got virally successful versus like this gets to a balance in all business and in all open source too, is just like, half your success is actually the product and half your success is how well you communicate its value and spread it, right? And
I think it might change that. I might personally change that to 10%.
10% product,
yeah, 90% how you communicate.
Right, well, exactly.
Which goes back to something you were saying earlier, which was that Facebook didn't do anything radically innovative. They just packaged existing tech in a way that made things accessible. And my personal belief, having worked in open source for 5 or 6 years now and seeing projects that are the most successful, is that that's actually way more important than the underlying kind of technology. And not for a bad reason either.
Correct,
for the reason that it's it's accessible. It meets people where they're at.
Yes.
And you could have the greatest lines of code in the world hidden in some subdirectory somewhere, and if it's not,
yes. So exactly. And so
basically people judge a book by its cover, and they have to, because they're exposed to so many different options every day to solve their problems or to make a choice about some consumer. So they end up using the surface level thing as a proxy for what's underneath.
Correct.
And so
right. And you
even
tie
if
that,
there's something good underneath, if you haven't put the work into the superficial level, they have nothing better to do than to discount the work.
Yes, exactly. And it ties into network effect stuff too, right? Where obviously for Facebook, that's a big deal for them. Like the fact that your friends were all there is what matters a lot. It keeps you there. But for like programming systems too, right? NPM is a perfect example of a technology that's successful for network effect reasons.
Yeah.
And
even though we all
even though
despise it,
you need
to be honest.
Do you need some link bait? You want me to throw some shade? I mean,
we've
it's
had
very
this conversation before. That's one of the things that I'm most. That's something that.
This is a good week to throw shade at NPM because everybody's mad at them for like very ham-handedly laying off a lot of their team. But my overall impression of them, even just trying to be charitable, is just that they had a kind of viral success and ended up in over their heads very early and have been in over their heads ever since. Yeah. And it's actually a perfect example of what we were talking about earlier of underestimating the difficulty of becoming a programming system. So like, as somebody who had worked with like, I don't know how many package systems prior to JavaScript and NPM, enough to know what's good and bad about a package system. You'd look at NPM and in the first 10 minutes, you'd look through the feature list and say, okay, it's missing that, and it's missing that. And you'd say, this is going to be painful. But you couldn't convince like the people who are excited about it because they hadn't hit those problems yet, right? Like you don't hit those problems till later or until you have a big enough ecosystem. Right. And it's things like, it wasn't until NPM 5 they had a true lock file, right? And even then it wasn't super great, and it's still what NPM considers pure dependencies. There's a concept there that's truly needed and truly needs first-class support and is still lacking, and it just causes a lot of pain and friction. And so it's like it was actually very heartening. And this isn't all NPM. This isn't all on NPM. It's also on Node because NPM followed Node's own conventions of Node modules resolution and stuff. The author of whom has totally disavowed it. So at this point, I don't feel like I'm throwing any horrible shade.
Yeah.
We can all hope for the success of the Yarn plug and play initiative, which like you can use it now. It's pretty solid. It solves most of the problems.
Could you give a little synopsis of that?
Yarn plug and play? Yeah. So it basically, at a high level, think about it, patching nodes require function to have a better way to do it. Right?
I see.
So it lets you have a single copy of each version of each thing on your system once, and they'll all wire up to each other correctly.
If you had to boil the problem with NPM down, it's basically from the step when require is called until the building of the dependency graph. That's like the root of the issues. Like that's where the resolution algorithm that yields a graph of all the modules is.
There's like there's at least 2 or 3 parts that are the problems. It's fractally problematic.
Sounds like exactly the kind of problem you want to have.
Yeah, well, choose, really. Sure. So no, I mean, like one problem is that the way the node modules resolution works, you represent your dependency graph as this tree on the file system, right? You have nested node modules folders. The problem is that a tree and a graph are not the same mathematical structure, and the dependency graph is a graph and not a tree. But to use the node module structure, you have to represent it as a tree. So right there, you end up with inefficiencies and confusions. And the specific example to make this concrete is like, if multiple of the libraries you're using, many of them use some shared dependency. If they all use it, you can lift it up to the highest level and they'll all share it. But if only some of them use it and others use a different version, you can't. The ones that share can't share. They all end up with their own copy. Right? There's no level in the file system.
Whereas if you had a graph,
yeah,
you would be able to do that. You'd have a new node.
You would just make a new edge.
Yeah, a new edge.
Right. So yeah, so like in the Yarn plug and play, it's just a new edge, right? Like the
interesting.
And all of that, and like for Yarn plug and play, they've tried to make it really fast. So they basically construct that list of edges once when you run the install, and then it's just so every require it literally just is a lookup in a lookup table. So it doesn't traverse the file system.
Does that mean like the node modules are all top level and the linking is done separately?
Yeah. Well, you don't even have a node modules folder in your project. You just have like a .pnp directory that has like the fairly opaque
some lookup
structure that knows where they are out in a cache somewhere. Yeah. So
that's pretty interesting.
Yeah.
Sounds pretty cool.
It's a big performance win. It's like in terms of how much you download, in terms of how much even traversal happens at runtime. It helps with both. It's actually also kind of critical. This takes us into Embroider and the build system work I've been doing because it's kind of important for that. I mean, not that it's a hard requirement, but one of the good things about Ember CLI as it is now is that it doesn't because it doesn't respect full node modules resolution. It's harder to end up with duplication in your Ember app, right? Like you can't it's hard to have 2 copies of the same add-on on different versions. Like Ember CLI doesn't really support that, right? Like
for Ember add-ons.
Yeah, well, so say for almost anything, but specifically for Ember add-ons, yes. If your app uses Ember Power Select version 1 and one of your add-ons uses Ember Power Select version 2, somebody just wins. It all flattens down to it.
Right.
So that's not always what you want. Sometimes you really do want duplication.
Right.
And it's weird. Like it's weird that we have our own resolution system. So with Embroider,
sometimes you end up with a Frankenstein version of it.
Yes, correct. That's correct. They even get merged. Yeah. So we know that's not great, right? So in Embroider, we just say no. Like let's just follow what the rest of the ecosystem is doing. Follow the node modules rules. That does allow duplication, but then it brings with it the problems that all node modules resolution has. So you might get more versions than you want.
Yeah.
And so now.
So what's the answer?
Well, the answer is that it's not now a unique problem to our build or even shouldn't. I don't think it should even be solved in the build. It's something that you want to run. Like at the time you're doing npm install or yarn install or whatever, you want to get your dependencies all resolved then, right? So there's tools for that already that exist. You can use yarn deduplicate. You can
dependency lint. Basically to tell you
stuff like that. Exactly.
The first step you'd want to know as a developer.
Exactly.
This is happening, and then you can decide how to deal with it.
Yeah. So you really just want to actually get that stuff flattened out. And Yarn plug and play would definitely fits the bill for that because it would like deduplicate things down as much as they can, right? Take advantage of all the edges where you can, and then use Yarn resolutions. You can even force things to deduplicate where it wasn't the original package author didn't make it clear enough that the range is wide. The range of supported versions is actually wider than they said, and you could like cheat. And so it comes up though, like when you test real apps, it does sometimes come up right away because there's certain things that don't want to be duplicated.
Right.
Various add-ons that do things that will like crash. More when they're. It's funny how many of the problematic cases I've found are places where an add-on author was trying really hard to be compatible with a lot of versions of things, and that being the stuff that breaks. So like I want to say like Ember Inflector, right, which is an add-on that's pretty core. It was extracted out of core stuff, and it used to extend the string prototype and put methods on it, and that's deprecated. But to try to be helpful, it does object define property to add like deprecation warnings on string, right? But of course, now if you load 2 copies of it, they both try to set the same property on that, and it blows up. Right? So it's like little things like that, where it just goes to show that like
it's the 10x thing.
Yeah.
The author of Inflector, when the developer was writing that piece of code, was never expecting their library to get run twice in the same environment. They weren't even thinking about that.
Right. Or going back even further, like the idea of extending the prototypes of the built-in objects, right?
Right.
That was trendy for a while in the web in general. But then everybody was like, yeah, this doesn't compose. These systems grow not understandable, and they break. And so everybody realized that was bad. So this was, and we know that's bad. We can obviously take that code out. It's old code at this point, but
interesting. So I want to get more into Embroider. I think that'll be something that's good to talk about. But just kind of to segue there, so I just, given our conversation about the 10x thing, when I first heard about Embroider, it was basically at EmberConf. And I guess the question to start this is like, for folks who are working on those libraries that you're talking about that don't have kind of the right abstractions in them, and you as an experienced person see that and you're like, okay, it's missing like a lock file or whatever, it's going to come back and bite them. When someone's in that position, what is the right move? Because I think part of the keynote this year at EmberConf was almost like an admission that this happened to us as well, right? There was lots of things that we tried to do at the systems level with Ember first launched, both the rendering engine, Ember Data, Ember CLI, all these things. And it turns out that it's a much harder problem to solve than you think at the beginning. And so it takes some time to what is the right path out there?
Sure.
And then to bring that into Embroider, just to be frank, when I saw Embroider, I was like, we just talked about all these things that we were doing, and it turned out to be too hard, so we're going to try to stop new work and then kind of finish what we started, and then it's like we have a new thing called Embroider.
Yeah, so there's definitely the exact trap that you're talking about that was identified in that talk, right, is this idea of trying to make too big a leap. And you're absolutely right that that's a challenge. So the way you and honestly, that was repeatedly the trap that was also preventing Ember CLI from getting better pre-Embroider. So the difference is, so there are both cases where we've messed that up and we've learned from them, and there's also cases where we've actually done extremely good job of moving to a whole better system in a gradual way or in a safe way that succeeded wildly. So our success cases are things like getting Glimmer 2 underneath Ember and things like that, where all the guts were completely replaced and in a way that was actually a decent upgrade for everybody. And
definitely agree there.
Right. So that, and so we've almost started, because that's a good success example, we tend to use the word glimmerizing a problem.
I see.
And the way you glimmerize a problem is you need to identify and design the small core of clean abstractions that you really wish the system had, right? The new thing, right? And in Glimmer, that was Glimmer's got a reference system and some very low level primitives around how you pull on a state and see and track what's changed and things like that. There's there's a bunch of code there. There's a bunch of abstractions there. Definitely lower level than what an Ember developer wants to deal with day to day. But like those, knowing what those abstractions were and getting them really clean. And in Glimmer particularly, it was like realizing we'd always thought about our templating language as a true programming language, growing programming language capabilities. Glimmer's implementation made that very clear by actually just implementing it as one. Like it's got internally, like calling a component is really a function call, and it works like a function call in the Glimmer virtual machine, right? So, and the number of primitive operations that virtual machine can do is actually quite small. There's only so many instructions that it has, right? It's like it's a very clean, elegant core. And that's a very big contrast from what it replaced, which was very ad hoc and had grown over time, right? So the first step is identifying that clean core, but then the critical second step is re-implementing the existing system in terms of the new clean core, right? So that's where like at least half the work is. It's the work that people tend to leave out when they try to do the jump, like they just like leap from the bad old thing to the better new thing. And people,
because it's easier to just leave people behind.
Yeah, it sounds
and
easier.
Just work
right.
with the new clean core, but the hard work is, and also the test of whether or not the abstraction is truly
it's actually
the correct one.
Yes, exactly.
So this is like, can Ember be rewritten in the new Glimmer? Can Liquid Fire be rewritten in Ember Animated?
Yeah,
same kind of thing.
That's exactly right. So you gotta, and so I don't, it sounds like it's harder to do the work to redefine the old system in the new primitives, but I don't think it's not like an extra cost. It's actually extremely valuable work because you do have this body of existing use cases out there, and you need to make sure they're all covered. And you definitely learn from the work of trying to make sure that the new thing can do all the things the old thing did in a like, and not just in a
less ad hoc way.
Yeah, not just in a hand-wavy way, but it can literally like down at the level of precision of actual code, it can do their things, right?
So that's going to be, Embroider is going to re-power the existing Ember CLI APIs.
Yeah, so it's that already,
ones.
right? So it's that already. Like existing apps work today, right? Like if...
so what is Embroider?
Sure. So it's a new build pipeline for Ember CLI. So to describe at a high level architecturally what it fixes, so when Ember CLI got started, it was actually controversial just to have a build tool and require it, right? Like we were definitely out ahead of the rest of JavaScript at that time. People thought it was really like, why I can't just have script tags anymore? What are you talking about? This is horrible. I don't want to have build tools. I'm not a backend developer. And we decided it was worth pushing on that, even though it was controversial, because we knew it was going to be critical. Like we knew that over time, the capabilities you get by having your own compiler and build system is just so powerful that you need it to give people the nice development experiences they want. So, Ember CLI was born and grew, and it's older than the ECMA module spec. It's predates all these other build tools that are now popular.
Babel even?
Yeah, or like probably at least contemporary with Babel, but yeah, like not much, certainly not younger. And so, the kind of prior art it grew from were examples like the Rails asset pipeline of the time, and stuff that we look at today and we're like, yeah, that was pretty hard to work with. We've learned a lot since then. These systems tended to be, I'll call them push-based. So like you tend to push code into your build, and so like most specifically, like just the act of creating a file in your app, like adding a new component or something, pushes it into the build. Like it's going to end up in the build. Or, and even more critically, like adding a library, adding an add-on to your app pushes a bunch of stuff into your build, right? Like you go and add, if you say add Ember CLI Mirage, a bunch of new stuff's going to end up in your app, even though you didn't do anything yet to try to use it in the app. Like, so everything's push-based. The ES module spec, and even before that really, like the web in general, if you think about the way HTML relates to JavaScript, relates to CSS, it's pull-based, right? Like you have an HTML file that refers to some JavaScript, so then you get the JavaScript. today, even just in browsers, you can actually say in that JavaScript, you can say it's type module, and it imports another module, and it will go get that one. And that's a more pull-based way of doing things, right? Everything gets pulled in. It's the pattern now that many JavaScript developers are familiar with, because it's how Webpack, Parcel, these Rollup, how these guys work, right? It was pull-based. They were all kind of built post-ES module spec. We adopted the ES module authoring spec very early. We helped write it. Like Ember people were at TC39 creating the module spec and making sure that it would meet our needs, and we adopted it before it was even final. So that has been actually, but we didn't ever really fully adopt the semantics of modules into our build system in a deep way to make it really pull-based, right, until now. So that's what Embroider is trying to fix.
Interesting. Very interesting.
So the saving grace that makes Embroider possible is that we adopted the authoring format very early, and it's very consistently used. So people writing Ember apps and add-ons are authoring modules, and modules are very analyzable in terms of what they depend on. So we haven't been taking advantage of that in the existing build pipeline, but the data is there. Like you can analyze the graph of what depends on what very consistently. So Embroider is able to compile all of our existing stuff forward into a new world where it is all statically build time, finding each other and pulling in stuff. So when you, the experience of using it on an app is like you change a couple lines in your Ember CLI build file to import the Embroider build pipeline. It's where you would have returned app to tree, you actually just take that app and you hand it to Embroider, and you return Embroider's tree. And you run Ember build, and it builds with Embroider instead of Ember CLI's stock build pipeline. We run you through there's a three-stage process inside the internals of Embroider is a three-stage build. The first stage takes all the existing add-ons, and the add-ons really are not, it's not ancillary. It's like, that's actually the interesting hard part of the problem of reforming our build pipeline, because add-ons are very, very powerful, what they could do today.
As opposed to generic NPM package.
Yeah, exactly.
So you treat them separately.
Well, certainly today, Ember CLI does, right, in a very strong way. Like they're really, add-ons are really programs that can emit code, right? They're full programs. Like when they emit custom broccoli trees, right? That's the implementation. Broccoli's neither here nor there. Embroider still uses broccoli. It's not like it's an anti-broccoli thing. But like the fact that add-ons themselves run arbitrary code to decide what code they contain when you go to build your app makes them not analyzable, right? It's all very dynamic. So so the first stage of the Embroider pipeline is actually to compile all the existing add-ons to a new format that is way more static. So as part of the project, we've been drafting a spec for like what we want the new add-on format to be, the publication format, like what goes on NPM. It doesn't necessarily have an opinion about the authoring format. That might even it could still be the same, but we give you a publish command that compiles you to the publication format that goes on NPM.
Can you give some examples, like where I would normally use like an index.js file and like a tree for vendor hook or something like that? That would be different, or? Yeah,
totally. So in the so the point is that in a V2 formatted add-on, which is as a shorthand for what this new format is, right? A V2 add-on would have, it doesn't have any tree for hooks. Right, so its code has got to just be there sitting on disk. That takes away a lot of the dynamism. The plus sides are that your build is now way simpler and faster because there's less work to do, and TypeScript understands your files, Sass understands your files, VS Code understands your files, because they're all just sitting there. You could jump to definition, and it'll know where they are, right? So that has a lot of benefit. So it takes away some of the power, and the solution to that is a couple of different features, right? So one is that in the V2 spec, like the Ember auto import type behavior, import from NPM is just standard. It's a thing you're allowed to do. So a lot of the stuff that you would have had to do with some kind of custom mangling of builds, just you do with that instead. That's less code right there. The other thing is that Embroider has a macro system in the sense of, the best example of an existing macro that people use is the Ember CLI HTML bars inline precompile, super long name, right? But that HBS backtick macro, right? You can think of it as a macro because it's a thing that runs in the build, right? It looks like a tag template string, but we run it during the build process and compile your templates, right? So, because it's like there's a Babel plugin.
It's not a runtime function call.
Yeah, it's a Babel plugin instead that handles it, right? So that's an example of a macro. Embroider carries with it, there's an @Embroider/macros package that has macros implemented both for JavaScript and for handlebars. That gives you things like conditionals that are going to run at build time. So you can strip out the code that's not needed. So you can have your, if the Ember version is old, include this compatibility code, otherwise don't. And so you can have that right in your code that you publish to NPM. And the difference now is that like the files on disk are all static there. And also you're not bringing any custom Babel with you. So like the spec says that add-ons publish JavaScript that uses ES latest features only. And so like nothing non-standard, like you don't, like if you wanted decorators, that's fine, compile them out first, right? Like anything that hasn't been finalized or that we don't include in this spec, we can choose which ones we include. There's actually,
I see.
Right?
So this is all happening as part of stage one? That's the first step, that you're
well,
talking about?
yeah, so the, so stage one is the compatibility layer that takes today's add-ons and compiles them up to the new format. So what that is going to do is, for example, like add-ons today do carry custom Babel configs with them, right? So that if you're authoring an add-on and you want to use something weird in your code, that's fine. So you end up bringing your own Babel plugins. You end up bringing your actual Babel version because it might be different than the apps, right? So you end up having to have Ember CLI Babel as a dependency, not a dev dependency. Right. So that brings it into all the apps that use you have to get that. They have to run that compilation step. They have to have many copies of Babel.
Right.
So that's not allowed in this new format. So the way the compatibility layer handles it is it will actually, for every add-on that we find that you need, that you're depending on, we will be like, oh, does it have any custom Babel plugins? If it does, we're going to actually just run all those plugins across its code first.
I see.
Right. We don't run the full like preset env.
Right.
We leave all the other stuff in.
You resolve custom Babel code. You resolve these macros so everyone's code looks the same.
Yeah. So the macros we should kind of push to the later stage. Certainly when we're talking compatibility, nobody's using them yet anyway. But the point is more that your custom AST transforms, also your custom Babel transforms, we run all those first so that now you're in a standard lingua franca. And for the templates, that's still handlebars that are not compiled because you can't compile till the end because you want to compile for the specific Ember version. Right? Like if you're going to publish to NPM, you can't compile your templates first. You want to leave handlebars. That's the stable language that you really want on NPM. Whereas the compiled format changes.
And handlebars is still statically analyzed.
Totally, exactly. Right? That's exactly right. So you compile out all those custom transforms, and then we also rearrange the files format in the add-ons so that the modules all align with node module resolution, right? So like what would have been /addon/index.js is now just your index.js, so that node will resolve it correctly. And where there's stuff that needs to go in the app tree for people who know about add-on development. Again, all of this stuff, add-on development being inaccessible and having these weird quirks is one of the problems we're also solving here, right? Like the fact that you need to think about app tree and add-on tree and this stuff, we want to make that not be a thing. But of course, for compatibility, like even a V2 add-on needs the ability to effectively copy stuff into the app's own package, right? That's if you think about what the app tree does, that's what it does. It's like, I have some code or some styles, it does both, that need to be, conceptually they live in the app's own like NPM package, its own module namespace, right? That's why when you make an add-on and you generate a component, you get this little re-export in the app folder, right? That's actually to make it so that when somebody consumes your add-on, if that add-on tries to resolve like my app name /component/power select, it finds it because it's in the app's own namespace because that's how all the module resolution works. Like fixing that in Ember, it ties into like the template imports work, and earlier attempts at solving that were baked into proposals like module unification. Like the leading stuff now is really around template imports to solve this problem. Anyway, so the point is that we compile all of the we compiled down the app so that it's now just a normal NPM library. Like the paths to the modules all line up with regular NPM conventions. We're in a lingua franca of the handlebars and the Babel. The special features.
So that removes a lot of the code from the Ember CLI build that traditionally was handling these kinds of one-off.
Well, and then, so some of the stuff like the app tree still has to be there. So you can have like the V2 format allows you to have a folder and then a key in package.json that says, I have these files that need to get copied into the app when you build me. But now it's actually just like a static key in package.json you can see and do it once. And so but this is an example of glimmerization and how do you safely build a new system that's a gradual step, because this whole first stage encompasses all the complexity of the old system, and then at the end of the stage 1 build, you have a complete set of packages that are all in the new world format, which is designed to be easy to work with. And so all the rest of the code going forward, you immediately are able to work in the new happy world, and you don't have to wait for, you don't end up having all these places where you're like, well, there's the new code path and the old code path, but we need to support both still. You've pushed all that complexity into stage 1, and stage 1 can get as complex as it wants to. It can be as slow as it wants to, because the goal is to not have it forever. You'll run it for almost ever.
Right.
But if any given add-on is going down a slow or sad or broken path there, then it's like now it's time to upgrade that add-on to V2 format. And when it publishes natively to NPM as V2 format, it does nothing in stage 1.
Right.
So
and then the stage 2 stuff, you're in a world that's much more constrained.
Yeah, and so in stage 2, it's much simpler problem now, because all of your add-ons are NPM resolvable with regular NPM rules. So anything that's their components, their helpers, their services, all that stuff is just sitting there on disk in places that you can find with regular resolution.
Which is why I see how it relates to the template imports.
Yeah, exactly. And then so in stage 2 is where we basically take an Ember app and a collection of add-ons that are in this nice to consume format, and we compile out all the Emberisms until we get to it is just HTML, JavaScript, CSS, that if the stage 3 isn't supposed to have to know anything special about Ember. It's just in stage 3 you actually use Webpack or Parcel or Rollup as plugged into this system as a kind of a plugin, to take what is just a collection of HTML files that refer to JavaScript files, some of which are modules, some of which are scripts, CSS files, right? And just optimize that, right? And so you can even have, we don't have this as a thing you can run, but in principle you can, and it'd be fun to do. You can have like a just use the platform third stage that doesn't do much at all, because the output of stage 2 is actually spec compliant stuff. Like it's HTML that refers to script type equals module. Here's my JavaScript, and all the things that are Ember specific are actually all compiled out by the time you get to that point. So what I mean by that is, out of the box, when you try Embroider on an app, we give you, if you don't change any settings, you get the most compatible settings that give you emulate the existing Ember CLI behaviors. So that means things like all the components that we find in your app, they're going to get into the build, for example, because there are cases that are very dynamic that maybe you expected it to be there, right?
So if you install composable helpers, you're going to have
all of them.
30 helpers.
Correct. So that's the default out of the box mode. But what gives you that is actually actual compatibility code that's running to go and find all that stuff. And basically, when we compile in stage 2, we're emitting JavaScript that says define my app /helpers /LTE, one of the composable helpers, right? As require this file, right? And that is basically, so now that's just stuff, that's stuff that Webpack, for example, understands and knows how to package that up. And then it's still plugged into the runtime system because we called the window define to get it into Ember's loader. Right? And so we do that for all of them by default. So, but then to get the nicer behavior where you don't get all the unused ones, you just turn off that code. And so you turn on the option called static helpers when you're ready to try that. Basically the adoption path is you get Embroider in and you see does it build, and maybe it doesn't, maybe we got bugs, maybe you have an add-on that's doing a really weird thing that we can't statically analyze, and you work through that. You get to that point, and now once you're working there, then you're okay, let's try to turn on static helpers. That's actually a really safe optimization most of the time, because it's actually very hard to dynamically invoke a helper. There's not a helper like the component helper. So most of the time that just works.
So Embroider's actually looking at your templates?
Yeah, so I didn't get to that yet, but yes. So Embroider's template compiler...
because we don't have template imports today, so there's a lot of implicit resolution going on.
Correct, but the implicit resolution is
still deterministic.
Static most of the time.
Yeah.
Exactly. So it does that, and it actually compiles the templates into JavaScript modules that have import statements. So
that's all code in Embroider?
Yeah.
Wow.
Right.
Is that hard?
No. I mean, yeah, I guess.
Sounds hard.
It sounds hard. It sounds hard.
You want to go try to do it?
Yeah.
Sounds hard.
It's not so bad. It's it was actually kind of I mean, this gets to your point about making sure you're communicating the value of a project clearly, but the vast majority of the work is actually the stage one piece. Is like getting all of the existing stuff into a position where you can then have like manipulate it very powerfully. That has been most of the attention
the
and work. Yeah. And so, but once you do that, like things like then doing this in build time resolution of all your helpers and components, they're like small extensions. It was stuff that I actually put off doing because I was like, I know that's easy once I've done the grunt work.
I see.
So it was like, I'll keep solving compatibility problems and do the grunt work. But then I realized, okay, like even though there's more of those, there's like a long tail of things to fix there. It's time to go and do the more fun features to communicate the value.
Right.
So but doing that was a very small increment on top of this, like implementing the static helpers. So we've got static helper resolution, static component resolution.
Yeah, that's the stuff you got to talk about, man, because that's like...
So that all works.
Starting at the end, I mean, why do I care as an Ember developer?
Exactly.
That's why I care.
That's a good question. Is what are the things that, as an Ember developer, what is this going to unlock for me?
Sure, exactly. So it already
unlocks. By the way, if you try to stand up from your seat before 2.5 hours, you might get zapped. So
yeah, right, exactly. I was actually thinking it depends how much time and setup we want to do, but like. If you have an Ember app and you wanted to spend 10 minutes and see if it builds with Embroider, it might just, and then you could actually use these features. Like we could do it today if you wanted to, but
it's pretty cool.
So the things that you can turn on, right? So I would describe the path as like first. So the README does explain how to try it out. It's like you change a couple. You add three packages, and they're three because there's the 3 build stages. They're actually they ship as separate packages. I'll say like as a preface. We do want this to become the standard thing in Ember CLI, and when it is, it should just work like Ember CLI does. Like there's nothing. You're not
going to have to learn about the 3 stages of Embroider.
Correct, exactly. That's really it's important that those are good APIs, but they're good APIs for people contributing to Ember CLI, right? They're not something we expect every app to learn about. But to like at this stage to try it out, you're going down the next level and like plugging it in, right? So you add 3 packages. So there's Embroider Compat is that first stage that understands how to take all your existing add-ons and compile them forward. Embroider Core is the second stage that knows how to take a collection of now V2 formatted add-ons plus your app and compile out all the Emberisms until you get something that's just JavaScript, right? And then stage 3 takes just JavaScript and optimizes it. And the stage 3 that's implemented right now is Webpack based.
Right. At that point, it seems like that's the least amount of. You can leverage most of the community work and larger JavaScript ecosystem there.
And that is totally the point. Yeah,
right?
Exactly. That's totally the point. And so most of, like, if you look at the code in the Embroider Webpack package, most of what's there is actually just making it, like Webpack's not very HTML oriented for its entry points. Parcel's more HTML oriented. That'd be a good one to try next. It would actually probably mean less code. The format that I've established as the kind of standardized stage 2 output is HTML oriented because it gives us more power. Like, the entry points are HTML, and then they could refer to JavaScript and CSS and things like that. But
can you elaborate just a little bit? Are you basically saying like you want to treat an index HTML file as the bootstrap for your application because
it is, right? Because when you run it, that's what happens, right? So yes, it's like you want to tell the final stage optimizer like. My main function is
for our browser to load up index.html,
exactly,
to follow script tags, to follow link tags.
That's what turns into the pull-based system.
Yes, exactly. So that becomes the root of the pull-based system, right? And it can support as many index.html files as you want. And and because in the JavaScript we support both static and dynamic imports across modules, you can structure the thing like that format becomes very flexible. And so we don't want to. The point is that by the end of stage 2, nothing that's Ember specific is still in there. Like Webpack doesn't need to learn what an engine is, for example, or it doesn't need to know what an in-repo add-on is, because all that got compiled out to just like, well, I have like I'm going to do an import, or I'm going to do a dynamic import of a lazy engine, but all of that is just
a JavaScript module, right? Which might have its own imports, which can be followed.
Right, exactly. So, So anyway, so that you add these 3 packages.
Okay, you add those 3
getting
packages.
back to the actual experience, right?
Yeah.
So like it would be the Compat for the first stage, the Core for the second stage, and Embroider Webpack for the third stage. And then you're changing like 2 lines in your Ember CLI build file. And the typical nice thing to do is actually use a conditional there, like make an environment variable, be like turn Embroider on. Yes. If you're not using Embroider, just return app to tree like you always did in that file at the end. But if you are, you actually just you basically pass that app instance into Embroider and get a tree out and return that instead. So it's small. And there's a place there to pass in options, but initially you don't need to pass any options. So then you can run your build and hopefully it works. If it doesn't, it's mostly because there is like still some things add-ons do that we can't quite analyze. And like, you know, there's a long tail of add-ons that some of them are doing things that are just strictly broken. Some of them are doing things that were legal before but are not now. But so in order to not block people, we have a pretty good system of basically compatibility shims you can put on top of any add-on to fix the things that are bad about it. That are like, because it's usually a very small amount of stuff. There's like, there's like this one file that it dynamically tries to load that we couldn't see that it was needed. So if you just like declare that it also needs this one file, everything works.
Yeah. Well, let's get to the good stuff because you keep going back to compatibility stuff. So what if it all works? So what should I expect?
So if it all
What's
works,
the point? What does it do for me?
Exactly. So right out of the box, you actually get some nice behaviors right away, which is like,
well, you won't have those 20 unused helpers from composable helpers.
So you need to flip a switch.
If you flip the static switch,
yeah. So the kind of like first is like see if it works. Right? And at that point, it's probably like, at that point, it's probably hasn't done much for you yet, but now you're really close to getting to flip some switches and get the exciting stuff. So
and you should just feel better because should you feel better in some way because like module resolution is probably going to be more stable in the future, or I'm going to have less bugs due to like modules stomping each other, or that's all like those are the switches.
So you're already getting some benefits in terms of, for example, right, like the Webpack's default production builds do like roll up like hoisting as an optimization. Among, like if it notices that a module is internally used only by some other family of modules, it'll just like compile it out, right? Like
so anything
you get some
the
of that
stage
stuff already.
3 thing
can
optimize on its own, given a set of HTML, JavaScript, and CSS. You'll get those things.
You get that already, and then like as I said, turning on something like static help. Well, so actually the first thing I would turn on is there's a flags for so all your add-on trees, all your add-ons that are exposing like just plain old JavaScript that typically gets consumed because you actually import it. Like the add-on tree. In a classic Ember add-on, right? You've got an app folder and an add-on folder. And it turns out like almost everything out of the add-on folder actually gets an explicit import that would pull it into your app, right? Like the components and helpers are in the app tree, and that's how they actually get found. Like they get found using the classic resolver, and it only finds things in the app tree. All the stuff in the add-on tree is almost always consumed directly by real static imports. So it's very rare to dynamically resolve stuff in there. So because it's rare, you can flip the switch that says, okay, don't force any of that stuff into my build. Like by default, for max compatibility, we're going to find every file that's in the add-on folder of your classic add-ons equivalent, right? Like, and make sure they end up in the build. You turn that off. So basically, you flip the switch that says, okay, static add-on trees, and now hopefully that works. Usually it does. If it doesn't, there's like 1 or 2 add-ons that were using a thing but didn't declare it clearly. Like as an example, something that I hit recently. The EmberMetrics add-on, the way it finds its plugins, like it does it dynamically at runtime, and so you can't know until at runtime that it actually needs the Google Analytics one. So you would have to then to keep people from getting blocked, because this is an ecosystem effort, right? Like you don't if you couldn't take advantage of any of these features till all your add-ons upgraded, it would never get done. Right. So instead, we have a pretty good rules system that lets you say, I see that EmberMetrics actually needs Google Analytics.
Right.
So there's a way to tell Embroider about that stuff external to the add-ons. And it's intended to get us there and get people moving. And once people are moving and trying it, that motivates the work to actually go upstream and fix the things for real. So,
but if you had an add-on that was compatible in that way that had explicit imports, you'd be able to turn that and then basically if you never needed like the serializer.js module from Mirage, you just don't import it and it's not going to end up in your build.
Exactly.
Today,
and so you get that immediately when you turn that on. And so even out of in a brand new Ember New app, you shake out a ton of stuff. 10K of stuff.
Yeah.
I mean, it's not a ton, but it's there and it matters.
And it also makes you feel better about if you're doing an add-on or writing a component library for your company. Like you can just add stuff, and it's just way better like that than to go and install a bunch of small libraries.
Exactly. So like even with just the static add-on trees, you get like a lot, like mixins and stuff definitely shake out, because like how do you use a mixin? You actually import it, right? And if you don't import it, you don't get it. So then the next level is. After you turn that on and it still works, then you turn on static helpers, static components. That will now, we drop that compatibility code that forces them all into the build. And so they get into the build because we traverse
the templates.
So at that point, we're still going to be like finding all your route templates and making sure they're in the build.
Yep.
But then they import their components and their helpers. So for the helpers is a very clear case. That's a big win you get right away, because as I said, helpers are almost always static anyway. So you turn that on and you're like all of a sudden Ember composable helpers, you've got 3 of them and not 30 of them.
Yep.
Right. That's a huge win you get right away. That works great. And then there's even stuff in Embroider's test suite that uses some of these examples, like composable helpers. Like it builds an app with classic build and Embroider build with these flag on. It sees that the set of helpers is got way smaller, right?
That's so cool.
And so with the components one, ends up being slightly more challenging because we do have these dynamic things people can do with them, right? So you can use the component helper to at runtime look up an arbitrary component. It turns out for the most part, what people do with that is still stuff we can analyze, but sometimes it needs a little bit of help. So this is again where there's a rules system that helps with this, and the rules are even shareable in the sense that we could bake some directly into Embroider, or we could choose to eventually move them to third party, like another library. But the idea being that we know, for example, that a very popular add-on like Ember Power Select, which also uses basic dropdown, it's deliberately very powerful because it lets you pass in components to customize lots of parts of itself. It's got 6 different component arguments it takes, right? So by itself, when you analyze its templates, you just see component helper invoking some arbitrary runtime value, and you're like, I can't know for sure if this is safe. Did this component get into my build? I don't know. So out of the box, when you turn on the static component stuff, you'll if you didn't have any rules in place, again, Embroider already brings with it rules for well-known add-ons like that. But if it didn't have any rules for that example, it'd be like, hey, warning, you've got a dynamic component helper here. I can't tell you for sure if it's going to work. And you could it is just a warning. You can charge ahead, and maybe your app will crash or maybe it won't when you get to that. But to fix it, you can declare. There's a couple very basic patterns that repeat over and over again in the add-on ecosystem. One is that the components you're invoking dynamically were arguments that you got, and statically we can't necessarily see that because it runs through arbitrary JavaScript code. It could go through computed, you could have defaults, all these things. So that's a rule you would declare to say, actually, this thing I'm invoking, that was an argument I was given. Whoever passed my trigger component, that's what I'm invoking. So you tell Embroider that rule, it actually moves the warning outward to your callers. So when they pass something in as trigger, if
they're going to be told, you need to let Embroider know what's the possible values here. That way, Power Select doesn't have to.
Right, and sometimes it actually just works out, because if they're passing trigger equals a string, it's a literal string.
Right.
We know what that means.
Right.
We can look it up right then.
Right.
And then we're done.
Do you see the key trigger, and you're just okay, I'm going to include this component that's passed in here.
Exactly.
Because you know how trigger the argument is used on.
We know that it's used as a component. Exactly.
Right.
So if they were passing the string literal, we can find it. If they were passing component helper with a string literal argument, we could find it. Or maybe for them it was also an argument they got, and you can make a new rule and pass the buck. Right. And the similar example is if you yield components, that'd be the same thing. You can make a rule that says I yield components. This is a component, but I'm basically certifying that it's a component that it's loaded because it's in your own template. If you yield a hash of component with string literals, they got included there. We know they're safe, so you can just declare.
So you need Embroider, basically 30,000 foot view. Embroider needs to build a whitelist of components that need to be included, and it can infer a lot of those from things like templates and some of the stuff. Sometimes you might have to provide it, but if it does have a complete list,
exactly. So then now you've got static component resolution. So now all your add-ons that you're using and your app code, any unused component doesn't get used. Doesn't get in the build, right? You stop using it, it's not there, and that's great. And again, if you're also using imports from NPM, whether that's so in Embroider, it's just a feature of the whole build. It's just understood that you can import from NPM. To polyfill it in existing apps, you can use Ember auto import. When you either of those cases now, right? If you think about if you drop the component that imports that library, you drop the whole library because it's all following the graph, right? So then the next cool thing that you get once you have static components and helpers is that all your components and helpers are getting included because they're included by some route template. So we have route splitting. So you can now, so then you say, okay, I would like to actually just split out some of my routes. I would like to choose split points and say, for example, I have an admin route with like a bunch of child routes under it that most people don't need. So let's split admin out of my main bundle. Let's make it lazy.
And that's basically because you'd still need something like the dynamic import function, right? The import function, what is it called? Dynamic imports?
Yeah, dynamic import is, yes. So that's what we're going to compile to at the output of stage 2 before we go to Webpack. Webpack's going to see a dynamic import. So I should, you can author in your app if you wanted to. If you're going to use Embroider and you're just going to only use Embroider, like everything I've described so far is stuff that's still compatible with the existing builds. The point is that people can, you don't have to, choose when to make the leap, right? It actually, all the things we're talking about, you can build your app with classic Ember CLI, you can build your app with Embroider and hopefully get a smaller, faster app. But you didn't do anything that wasn't backward compatible. Right? If you're only going to build with Embroider, you don't care, you can actually just start authoring with dynamic import anywhere you want to, and it will do the right thing. So
that's what you would do today if you were starting a new app. I mean, granted, you understand the system.
Sure. Yeah, I mean,
you could build with these flags enabled and be working under these constraints.
Yes, that's right. Anyway, and that works. So you can use dynamic import. That's fine. It does mean dealing with the asynchrony yourself, right? Like dynamic import is a promise for the module, not the module. So it's not always a drop-in if you're used to getting things statically and synchronously. But you can totally do that if you want to. The other point, though, is that because of our convention, so as long as you're doing conventional routing stuff, which mostly means you're not overriding the render hooks and things to pick to make route A actually use template B and weird stuff like that. As long as you're not doing that stuff, the route splitting will be able to do all this for you. So you just declaratively say split at routes and you list some names or regexes and that's it.
You won't change the way the imports look. You won't return an import from a model hook or something like that because
no, you don't have to do that because we know the
asynchronous boundaries.
Yes,
based
all
on
of the lookup is already Ember, right? What imports your route template? Well, Ember does, right? So we can then synthesize when we do the compile. We can say, they chose to split at this point, so we're going to find the template for that route, the actual route file for that route, and the controller for that route if they all exist, and its children because you split all the children. And we're gonna, instead of compiling, if you weren't splitting, we were gonna compile them into the main entry point where we just say define my app /routes /blah as require this file, right? That's where we would have done the force it into the build, to get compatibility. But instead of putting that there, we actually make a separate file for these routes now, put it there instead. And we have a little function in the main entry point that is load my lazy bundles with the dynamic import statements in it for each of those bundles. So that
in user land, you don't have to be writing those.
Correct.
That's where the dynamic import function is.
Yeah.
Damn, that's pretty cool.
Right. So, and this works and it's deployed so Ember Observer has been a good open source app to try all that stuff on.
Yeah.
Beta Ember Observer is deployed with full route splitting.
Oh, cool.
I didn't change anything in Ember Observer. It's I didn't pick it because it was an easy case. It's an existing app with quite a lot of history, more features than are obvious because it has a whole admin section, and it uses a lot of add-ons. It was because it's deliberately trying to dog food the add-on ecosystem stuff. It actually uses a ton of features. So, and it worked with no changes to the app. So the one change you make to turn on this routing feature is there is an Embroider router package, which is a very tiny extension to the basic Ember router, mostly just so that we can, when you're about to enter a route, that's when we get to run some code to be did we load it? Let's load it. And it's just actually stole code out of the engines package. It does the same thing engines do. So so to turn on route splitting, the change is you add Embroider router. Instead, in your router.js file, you import from a new thing, the Embroider provided one, not the Ember provided one. But you don't change anything about how you set up your routes. It was just the import statement you changed. And then in your Embroider config, in your Ember CLI build file, you say split out routes, and it works.
Cool. Is there what happens while the bundle's lazily loading? Is there a loading template that gets rendered or?
That's a good question. Does it hit the loading route? Yeah, I guess it would. It would go through the same paths that you would. So it doesn't. It's not parallelized with like the data loads. And Ember's own routing data loads are not really parallelized, right? So they serialize down, they waterfall down. So this is still in that mold.
But it's like it's a blocking render in a sense. It's blocking the page load in the same way that a model hook takes a long time does.
Yeah, that's
so
right.
you kind of expect that would be your first guess.
That would be my mental model.
That's actually a good point. I haven't like gone and tested that, but I'm pretty sure that would work. And
you would have like the link is active class or is activating or whatever. Basically all the stuff that helps you build like the loading UI.
Right. And this did, like I said, this took advantage of the exact same pattern that the lazy engine stuff does, so that we know it basically works with the existing stuff out there. And like obviously, like I've been telling people for a while, like yes, lazy engines are painful because they're not really built for lazy loading.
Yeah,
that's like a side effect of them.
I was going to say, we just talked about this at EmberConf, and basically this is a better solution to the problem of code splitting, because while some people have used engines for that, really the purpose engines was designed for was to help big teams work on separate parts of the app without stepping on each other's toes, having good isolation and boundaries.
Yeah, and those boundaries really hurt when when they don't match real organizational boundaries.
Right.
Yeah, exactly.
But people, or I guess the route level code splitting was kind of shoehorned in, or it became like a strange side effect of engines that's wasn't part of why it was built. And so it's not actually, if you need route level code splitting, you shouldn't just start using engines to accomplish that.
Yeah, exactly.
It's better solved by this, it's
definitely better solved by this.
Because you don't have to make any changes also, but it's also the right tool for the job.
Right, exactly. So it's really good. It's very gratifying to see it out. Like, as I was saying, like most of the scut work was actually building up getting all the ducks in a row so that you're built and
statically analyzable.
And once you've done that, now all this stuff it's a very small amount of code where it's very easy to extend and do these features.
Just don't forget, just because it's a small amount of code doesn't mean you should talk about a small amount.
Correct.
This is like the most important stuff.
Definitely.
I'm just going to keep hammering on that. Absolutely. Sorry, this is the EmberMap podcast. We don't hold any punches here.
Yeah. That's right. Exactly. Yeah, no, so I'm very excited about this stuff. It works really good. Like I said, so the status of the project is really like people should absolutely try it out.
Yeah.
It's designed to be unintrusive so that you should be able to try it out. Even if your app is one that you have to be conservative with and you're not ready to commit, trying it like with a feature flag, for example, or making it run on CI only, right, is actually a very easy thing to do. If you wanted to just make sure you're staying compatible with this future world.
I see.
Because it's
what about add-ons too, like running Mirage against, using it to build Mirage, or like to have CI run a version of it and let it fail, but then I could just see. Yeah,
so that's a great question. That leads me to kind of what is my next steps actually. Mm-hmm. So I think, it does work. Like if you're in an add-on and you want to just build it with so what that means is really you're building the dummy app and the test suite with Embroider. That does work. We test that in the test suite of Embroider, that like we do support dummy apps. We had to do special things for them because they're too weird. Yeah. Again, like compile out the weird embers, right? And but I think that, and that would not be a bad thing for add-ons to do, but I actually would rather, if we're going to ask add-on authors to do things, I would actually rather get them onto the V2 format natively. And so my next step is to get the draft spec that we have there's a spec in the Embroider repo. You can go find it. It's like spec.md for what the new format is.
I see.
But there's like a few loose ends that I want to wrap up very soon and make an RFC out of it. The reason that really has to be the next step, because we don't want to tell add-on authors to start publishing this new format to NPM unless we actually know what the new format is. So, but it's actually quite close because most of the core of it are very stable already. Like we've been going long enough now. I mean, so Embroider's been being built for like more than half a year now. This isn't a new thing. And like apps are, like big apps have been tested against it, and lots of add-ons have been tested against it. The core of what this format is very stable now. It is time to do an RFC.
That's great to hear, by the way. I think that was just having not known the history of it at all. I'm sure people who follow like all the repos and stuff know, but I didn't.
Well, initially I was deliberately not advertising it.
Yeah.
Partly because until it reached a certain level of success and maturity, I did not want to suck all the oxygen from the rest of Ember CLI development.
Yeah.
Right?
Yep.
I think now it is mature enough and appropriate enough that like
You're convinced it's the path
where we
forward.
want to do new
Yeah.
things. But it was early on. It was just me trying to prove that it would work,
Yeah.
and I deliberately didn't want to come and stomp on all the other stuff going on, right?
Yeah.
So now it's appropriate to like tout it and market it and teach people about it. At the very beginning, I was deliberately it was open source from the beginning. I didn't like hide it, and I've been talking with lots of like the whole Ember CLI core team knew about it. We talked about it. Framework core team knew about it. We talked about it. It wasn't like a secret, but it also wasn't a thing that I wanted. Wasn't ready for people to use, and it was like it did stomp on other ongoing work, right? So like
it makes certain work obsolete.
Yes.
If it becomes adopted. Yep.
Yeah, exactly. So, and that was a conscious decision to just like, I think I see a better architecture. I could do this. I certainly talked about that architecture with other people and taught and like tried to guide, and it's like hard to explain some of these things. So I was like, okay, I have to show what I mean.
Right.
And go and do it first. So that's what I went off into the wilderness to do and come back.
Was there like a specific problem you were facing in one of your apps that was like, I need this,
To
like, I
motivate
need
this?
this thing to exist?
Well, yeah, I guess that's yes. A lot of this grew out of me doing Ember Auto Import. So when I did Ember Auto Import, that was very motivated by direct community feedback when we did the first big round of like, hey, like everybody make your blog posts about what you want Ember to do in 2018, right? We did this whole community road mapping process, which turned out to be very useful and valuable. And everybody was like, I just need to be able to import from NPM. And I mean, at an intellectual level, I knew that was the thing people wanted, but the
You got nerd sniped, Ed.
yeah, it's easy to right. It's easy to forget once.
Which we're all very thankful for.
Yes. Once you know all of the paper cuts, it's hard to feel them, right? So
yeah. So that opened your eyes a little bit to some of the pain points.
Yeah, and so I realized that I already had a lot of the machinery, and like I had already made Ember Browserify long before. It was kind of solving a similar problem, but it was different, right? Like just different enough Browserify was just an older infrastructure to build it on.
Yeah.
And so I was like, okay, like I can see how I solved this problem actually quite quickly, and it worked great, and people liked it, and it solved a big chunk of the problem. And as soon as you have these capabilities to like pull things in on demand, you start to say like, okay, well now I would really love to be able to like actually propagate that and say, like, I want to auto import an add-on. I want to dynamic import an add-on.
I mean, the pull versus push thing made it very clear to me. Like that, to me, that's like the whole thing.
Yes.
Basically.
Right,
like
exactly.
That, and so once you see that, you're like, wait, if it was all pull based, it's like, boom, so many things just fall out of that.
Exactly. And auto import is pull based for third-party things, but it can't do the Ember pieces. And the reason
because
it
of the
can't
dynamic pieces.
Yeah, the reason it can't is precisely because of like the lack of the Embroider first stage that gets us there.
Right.
So that's kind of what led me down the path. In terms of what real apps need, it totally is a thing that real apps need and want to do, like code splitting and tree shaking. People care about that.
Pay as you go.
Yeah.
Usage of libraries.
Exactly. It really helps you not have to worry about. It lets you design better libraries, right? It's like, as we've talked about in terms of coming up with what would be the best ergonomics for Ember animated imports, right? Like, if you could take for granted certain kinds of pay go.
Right.
Then you can design better libraries, and you can keep more batteries included libraries and not worry about having extra stuff, right? So all of that is very good, and also, you can
also tweet that Ember has route splitting.
Correct.
Which is a great thing to be able to tweet.
Yes, exactly. I mean, it's closing a gap. It's closing a hole in our capabilities, right? It's not a thing. I mean, it's a thing that I hope Ember people are very excited about. I am definitely.
I think people are very excited about it.
Of course, it's like it's a parity thing. It's not a jump ahead thing, right? But that's fine. It's good. Honestly, the thing that I think is worth touting and bragging about is that, like existing apps that that are, not legacy code but revenue code. Right? The code that actually makes money. That were written long before code splitting was really a thing. Get this feature.
I think that's gonna be every year that goes by. that has more 4, 5, 6, 7-year-old apps that are all on the latest Ember version and get the benefit of Ember's conventions, but also have these modern features, is just going to be more and more of a compelling reason to use something like Ember. And even, just yesterday I was pairing with a buddy of mine, and we were doing some Vue development, and we were trying to understand how to do even just a brand new Vue app with Vue router, and getting something equivalent to Ember's model hook, where you have a dynamic route with like a blog post slug, and getting the app to block on fetch. And then when you switch, if you have like a master detail view and you click on the second blog post and you want to like re-render this, it's actually pretty confusing. Like there's not the equivalent of like a model hook.
I see, yeah.
You have to like either watch the route, or you have to do like a before route transition and then like a route update thing, and it's like some duplication there. So I still think Ember has tons of Ember's always been like this, trying to think about the whole app from the beginning. Like you're not just going to need the rendering layer, you're going to need routes, and you're going to need them to have dynamic segments. Exactly.
It's
the problem is when we don't have a seat at the table because of things like route splitting not being part of it.
Exactly.
So I think there's still a huge value there if we can keep up with that. And I love the idea of having like the compatibility layer being where like, oh, Ember gives you this extra stuff, but then now you're in Webpack land, or so you just draw the Ember circle around a smaller piece of it, and instead of saying this is all Ember from this to this, and so you either get it or you don't.
Right.
There's awesome things that you love about it, and then there's things you're missing that you
exactly. And so it's all about letting us. It's been definitely a theme throughout. Like Octane itself, a big theme is things that we had to do ourselves in the past because they literally didn't exist.
Right.
We don't anymore. Right. Like needing our own object system was a thing we absolutely needed.
Right.
You don't now. That's great. And this is similar.
It's even we don't have class properties still. And it's like, there's still some nice things about the object model, but like we're getting the class fields, and like that's going to finally be the thing. But people don't realize there's like a gap.
Yeah, there. I mean, the biggest thing that has been a real struggle at the standards level was decorators. Yeah. Because if you think about Ember's classic object system, it had decorators in the sense that like DS adder or computed are effectively our decorators. Yep. And so we've had them and needed that, like saw the value. They're a thing you definitely need and want. And it's not an original invention, right? Like other languages have decorators. It's a thing you definitely need to grow if you're growing these kind of capabilities in a framework. And so it's been a long struggle to get that into the JavaScript, the language, and it's getting there. Like there's so many people working so hard on it to get consensus and to do multiple iterations of designs. It has been partly a struggle because there is there's definitely philosophical differences about JavaScript, the language, and people who have like framework PTSD from other languages not wanting JavaScript to get frameworky. Because it can, certainly people have had bad experiences, but that doesn't mean you can't use these things well also. And
Interesting.
There is definitely pushback on any features that seemed too frameworky from just like a certain subset of JavaScript language people.
The kinds of things that the Ember community values ergonomic-wise, the things that we're not willing to give up, like something equivalent to a decorator, but then this other group of people saying like those are the kinds of things we don't want to be in the standard platform.
Yeah, people wanting to push JavaScript to be more explicitly a functional programming language, right? Like saying, I would rather solve that with a functional programming paradigm. And it's just realistically, it has to be a multi-paradigm language. All successful languages are multi-paradigm to an extent. To be purely functional is a real extreme position that has never hit mainstream adoption.
You're going to break JavaScript if you make it purely functional.
Well, correct. It's already not, right? It's exactly. So it's like...
Yeah, what are your options, really?
It's already not. You got to just deal. And so, I never doubted that we would eventually find something. We're getting there.
Yeah.
The latest spec, and so it was a little bit of a dilemma because it has taken so long to get the decorators into the language, but we really did want to give people the benefit of like most of what we need is already there in the JavaScript object system. Like using native classes is nice, using native getters is nice, tracked properties and all that are great. And so we had to basically say, all right, decorators are not stable, but we're going to commit to them anyway because Mostly because we're committing to a specific set of decorators we provide, and not saying that like if you write your own crazy decorators, they're going to necessarily work in a future Ember app. We don't know if they will, but we can commit to like re-implementing our own decorators on whatever the future spec is.
That's what Chris was telling us about, like the static decorators, or like the decorators that are different than just arbitrary.
Exactly, and that's so the
calls.
static one is the new proposal, exactly. And he's been like working very closely on all that stuff and following it much more closely than me. So like I brought that up just in the context of saying that like Embroider third stage is the same kind of thing. It's like we had to do our own thing once, but we don't anymore. Like there's actually good general purpose tools in the ecosystem. Let's use that. And not even commit to one, but to keep an API boundary where in the future we could like pick the next one that isn't even written today, right? My hope is that somebody goes and makes like a pure Rust bundling transpiling system that's like 1,000 times faster than what we have today, and we can drop that in as our third stage, right? Like that would be amazing.
That's pretty cool.
I think Ember users are going to trust us a lot more, just knowing that it's not, a one size fits all solution where they know that like. A question we used to always get was why doesn't Ember use Webpack?
Yeah.
And they're not like asking for like a technical thing. They're really like when you unpack that, they're getting at like why doesn't Ember use the rest of the JavaScript ecosystem?
Yes, exactly.
Yeah, there's two ways to interpret that. One is like, oh, these are people who are naive and going with trends and they don't have experience to understand the technical trend. Another is like what you said, which is like, wait a second, this is just weird. Like every other community uses this thing or writes classes or whatever, and yeah,
exactly.
And obviously, like the whole core team understands this. They talked about this in the keynote, and it's great to see the work happening.
Totally. It's also worth like this comes into just having a balanced and mature view of technology adoption, where it is worth using a thing that has there's a lot of warts I could complain about with Webpack. You have to balance that with like what you said about being weird, or about just the fact that even if what Webpack does is quirky, like if it has weird behaviors, for example, in how it packages art libraries, just the fact that it's the thing people use to package libraries means that most library authors probably fixed their stuff so it will work in Webpack, right? So like there is totally adoption story stuff, network effect stuff that makes it compelling. It's the same reason you'd use NPM, right? NPM might not be perfect, but it's where all the stuff is. So let's figure out how do you mitigate the downsides and the warts for our community by having some basic conventions around it, and still get the network effects of adopting a technology that has a lot of effort pouring into it. So, when it comes to Webpack, for example, in Embroider, I think it's a perfectly good choice for the third stage, but I don't want to lock us into one choice forever, right? And so when we pick when we finalize an API for what Ember apps will do, when this is like the default in Ember CLI and you don't look at it, I want to make sure that we have, what we're not going to do is commit to supporting the whole API service of Webpack, because then you really are locked into it forever. Right? Instead, it would be like, okay, what is the 80% API of what add-ons need to ask for from a third stage packager? Let's expose that in an API that we can actually commit to. And it's a very thin layer up in front, right? And you want to even make it look like it shouldn't look weird or hard to do for somebody who understands how the basic config. For an app author who wants to inject some custom config, I would never gonna close that door. For an app author, it's actually kind of okay. Like you basically would want to tell them that, you might be locking yourself into a particular Ember CLI version if you're doing weirdly custom stuff.
Right.
But if it's your own app, that's not such a big deal. What is really a big deal, and the bigger wart with Webpack configs, is that they don't compose out of like a many authors situation. So you really do want, for Ember add-ons to work as out of the box as they do, you really want them to be able to ask for things from the final stage packager system. And trying to do that in a Webpack world is it's not a thing it's not really designed for that. There's an assumption in their design that the application author controls 100% of the config.
Yeah, whereas like you might want to write an add-on that's going to look at some aspect of the final build to generate an asset map, let's say.
Yeah, like there's various things you might want to do like that.
Yeah.
That's one example.
Yeah.
Or even just making it so that, like TypeScript integration is an Ember add-on that does the right thing. you'd really want, like, that is going to effectively, in a Webpack world, that's going to install a TypeScript loader and configure it with good defaults that plug into our builds and our notifications and all that. You want to be able to do that in a way that, so that users can just still install Ember CLI TypeScript and have it. And then if a future version of Ember CLI swaps Webpack for something that hasn't even been written yet, that's better in some way, we could keep that working, right? That would be the goal. So you don't want, if everybody was just emitting, if we let the add-on ecosystem start emitting pure Webpack config, then you're locked in forever.
Right.
So,
Interesting.
Yeah. So it's like, so that's like the remaining work to make it. As I said, one of my next things is I want to get the V2 Addon spec as an RFC so that we can get it adopted. And
yeah, let's take a quick break.
Sure.
I think we might be losing this room.
We also hacked our cameras to be able to
They like light on fire after 30 minutes. So
that's
we
funny.
did some firmware hacking.
Nice.
Yeah.
I love it. That's great.
That's the difference between you and me. I hate that stuff. I want it to just Apple product, plug it in, don't work.
Right. No, I've definitely learned. I've learned a more balanced approach to that. Like, honestly, I think a lot of the benefit you accrue from being into technology in younger life, like getting into it as a kid or getting into it as a college student, is that you have just this like absurd ability to spend time on stupid things.
Yeah.
Not even stupid things, but just like things that are not the highest value thing you should be doing right now, right?
Right.
Like, and you're not over optimized. You haven't been like, capitalism hasn't drilled it into you that you got to optimize that time. Time is money and all this stuff, right? So as a kid, also just because like whatever interests you doesn't feel like work and you do a lot of it.
Right.
So like you spend crazy amounts of time like
regex parsing something, even though you can use a library for it, just learning something.
Tinkering, whether it's with hardware, whether it's software, and all that tinkering time, like you osmose a ton of knowledge when you do it, and it's like, it gets a little into the whole like, how, this has been debunked, but like the 10,000 hours of mastery kind of theory of like, the more time you spend doing something, you absorb skill. And it's, as an adult, when you try to spend that time, it feels very expensive and hard. But as a kid or like a young adult where you're just playing, it doesn't feel like work. And so you sneak all that experience in.
Yeah, it's like when I started programming, I was just like, you're being totally inefficient, but you just don't care. You're just hours and hours having fun.
And that's actually advice I do give to even working developers, which is, there's a very concrete way in which you can do a thing that feels inefficient but isn't, and that is like when you hit a bug at the next layer down, like in your library that you're using, in your framework that you're using, it feels like it's probably not worth your time to debug it. Like it's not my app, it's not my code. Why am I doing this? But that's like the shortest path to leveling up dramatically in your capabilities, is the ability to do that. And you get better at it quite quickly if you do it enough. It's like, I found a bug in the next layer down. Let's actually debug what's going on. And the first time it'll be hard, and you're like navigating somebody else's code and you don't know what's going on. But like that practice is what makes you level up dramatically in your development skill, and being able to, so like on the first, like on an individual bug instance, it's probably not worth the time, but the ROI of that time in terms of your skills is totally worth it, because like the next time and the next time and the next time you hit that bug, you'll get faster at it, to the point where on an individual bug that you hit, it's actually still worth your time to fix, to like even at least understand it, if not fix it, because you can traverse the other people's code so much faster now.
Interesting.
Right.
That's really great. Also too, it could be like in another language. Like, and that's,
that's right. And that's how you learn. Like reading code really does matter. Like you learn by reading, you learn by imitation. But how do you read code is a thing that nobody teaches you, and it's not linear. It's not like reading a book.
Right. It seems like the kind of thing is way better over time in small chunks, especially for things that you're motivated by.
Exactly. It has to be. You need a motivation, and then you follow the threads, right? And that's how we really read code, and that's why we read code. You read it because you're trying to fix something, or you're trying to understand something very specific, and you need that motivation. Like code reading has to always be motivated. Code reading without a motivation is very amorphous. I don't know how you would even do it, right? So, but when you happen to have that motivation, that's actually a huge opportunity. I've thought about whether you could even design a kind of a teaching resource
that errors and levels.
Yeah, by finding those motivations, right? Yeah. Like I could imagine actually curating, having some heuristics to try to find examples and then curate them of like what was a PR that was made in a popular open source thing this week that, you know, like the actual code changes were like not giant. They're like a digestible amount of changes. People had there was like an interesting amount of discussion about it, and then it got merged, right? Like if you find examples like that, and then like you look at, okay, what was the bug or feature that motivated this? Let's start with that bug or feature with this code base before the change. Let's use that as our teaching example, right? Because now you have a motivated, you have that motivation to go read foreign code that's not yours. Right. Maybe it's a new language, maybe it's a new framework, and dive into it. And like, how does an experienced programmer approach that? Right. That's like, I think that's really good teaching.
Yeah. There's two examples that kind of you just reminded me of. One is like, have you ever seen those things where there's like a failing test suite and your job is to get the test suite? The Ruby has one.
Right.
Or whatever. Yeah, something. I don't remember the name.
I think it's like Ruby cones,
maybe that was
Kata or something like that.
But those are always great because they force you to dive everywhere. And then the other is, I know there's like the capture the flag. Security those challenges where those I feel like those really force you to go learn something.
Those are very fun. Yes.
Yeah, they force you to just learn these weird like things that you'll never come across.
Right, exactly.
You have to like level up through these. Like,
and actually, both of those complement each other because the one problem with the failing test suite approach, like it's a very good approach. I like it a lot. It is how we do most of our work as programmers. Is like there's a thing that doesn't work. Let's keep working till it's fixed.
Right.
The problem is. You do plateau if you're operating in that mode because there's a lot of problems that can be like once the code runs correctly, you're done. But there's lots of other programs where that's not the end, right? Like it doesn't force you to learn taste and design of APIs and things, and it doesn't force you also.
You don't have always such a neatly failing case.
You're saying it like it's green, you're done,
right?
But you're not learning like, did I do the boundary right?
Yes, exactly. And so doing the boundary right is like, you know, it's about learning style and judgment and taste. And so it's easy for programmers to fall into the it works so I'm done. And like even people who traditionally teach TDD they try to tell you it should be red green refactor, right? You're supposed to go do the step where you make it nice, but it's easy to forget that step. It touches on security too, because security is a problem that you absolutely cannot fix with the turn the suite from red to green problem. And you see hilarious examples of this even from very professional teams where, effectively somebody finds a security flaw and they produce a proof of concept that says like exploits the flaw, right? And so the maintainers take that proof of concept and they think about it like a failing test. So they're like, I need to make this not work anymore. So they like overfit the solution. They make sure that proof of concept doesn't work anymore, but they didn't understand or fix the problem. And because in security, like it's never enough to kill one flaw. You have to understand the bigger structure about why that flaw is there and fix the class of problem. So this is an area where it's just like runs for me is never good enough in security, right? Because if you didn't deeply understand why this flaw existed, you don't know if you really fixed it. It's literally impossible to write a test suite that will tell you if you fixed it, because the whole point is that there's this big universe of possible inputs that are
you haven't
unsafe.
Foreseen it. Right.
Exactly.
Interesting.
So it's like that's where you're forced to go and do systems level, mathematical structure level thinking, and I think there's a huge amount of actual math that programmers do, even programmers who think they don't like math, right? I've said this before, but ones with a lot of experience do get good at math in the sense that mathematicians do it, where they think about the shape of problems, the structure of entities and problems, and is this universe of objects that I support, is it a closed universe under this operation? Like, can you ever escape by accident into an invalid state, right? Like, and if you need that level of abstract thinking to like close security problems or to write code that doesn't have security problems, right? It's because you have to mentally you're operating not on a single input at a time, but on the set of possible inputs, right? And it's similar when you designing APIs well is not that different. You have to you're supporting the set of possible programs and not one program, right? And it's a big leap in abstract thinking to get to that level. And if you only ever like turn test suites from red to green, you don't get there. So you need kind of both paths.
Well, it reminds me of what you said at the beginning, going the grid, the 2x2 grid with the 3x and the 9x, because when I first made Mirage, it was for apps that we were using at TED. And then when you open source it and other people start using it, you just see everything changes.
Totally.
So yeah, let's, we have a few minutes here just to wrap up. Why don't we just finish? I think you were just talking about like your next steps for Embroider, where you see most of the work happening.
Yeah, so like next step, I want to rapidly have an RFC for the add-on format. And at that point, like when we can get that merged, and I don't think it's hard. I think like there's a core of it that's already very stabilized and solid, where it'll be I would hope to call it a slam dunk RFC because the work's been done. And
there's not a long design process that needs to happen.
And it doesn't have to cover every edge case. Like this is, again, because we're not going to do the dangerous try to jump the chasm. We're doing this is a gradual step, trying to do things the right way. There's no reason we have to cover every edge case of what add-ons do today. If there's a thing an add-on truly needs that we don't have in the new spec, fine, stay in V1 until we're ready, right? Like we can add to it additively. We don't have to do a giant design up front. But there's a core of stuff that's already solid that I want to get in our RFC. And when we do that, add-on authors can start adopting that format. And it has a massive impact on, well, so for one thing, it'll make them reliable in Embroider, and that's great. It helps even in like classic Ember CLI. I think it'll help people's builds get faster because you do less dynamic stuff, right, in your build, and it has a massive performance impact on Embroider. So build performance wise, when you adopt Embroider, I've benchmarked a couple different apps. With the full compatibility on, it could be like 10%, 20% slower than what you have as an initial build. The incremental build is just as fast. But when you get to the point where all your add-ons are pre-compiled to V2, it's like way, way faster, like 50% more faster. So it's worth doing, right? Like people will be excited by that. And that'll help motivate a bunch of work of cleaning up dynamic stuff in the add-on ecosystem.
Right.
So like I want to do that right away because that's really what's going to help us start to tamp down the long tail of bugs that would make Embroider not stable. It's like add-ons doing dynamic stuff. So if we can, that's basically why the RFC is the next step. Because then we can actually just go upstream the fixes to all of them.
Get people using it. Get more and more add-ons.
Yeah, and
have
we need
less compatibility issues.
Right, and we need people to start using it now. Like people should absolutely please try it.
Yeah.
There's the README says how to try it. People have been trying it and filing bugs for me, which is great.
Yeah.
Like you should come in with the expectation that like you'll try it out and you'll probably get a build error, but you should report that build error and then we'll make sure the next version doesn't have that build error. Right.
And maybe even dive in and try to understand it yourself.
Totally. Oh yeah, absolutely you should. Yes, absolutely you should. It's written all in TypeScript, which gives you quite a lot of exploration. I mean, if you don't know TypeScript, then maybe that's an extra barrier. But if you want to learn it, maybe it's a good chance.
And motivation.
It gives you. It does. Part of why people do like TypeScript is it helps with that process we just described of diving into a foreign code base and navigating it because it does. It's a system like TypeScript is designed for that use case, right? It's trying to help you understand the constraints and the boundaries and what uses what in a foreign code base and follow those threads. Like a type system is designed to help with that. So it does even something like the options that Embroider accepts, the fact that like they're typed helps. Like you can, if you try to do something that's non-structured, if you use VS Code even just to write your Ember CLI build.js, even if you're not writing TypeScript, because the options themselves are defined in TypeScript, it'll actually tell you if you said something that's not possible.
Well, that's
very nice.
Yeah, these are the things that are I think we'll be seeing these benefits more and more as people start using it, and some of that stuff you won't really be able to communicate until you feel it, and you feel your app building faster, and you feel confident when you're setting an option for an add-on. That's the kind of stuff I think that's actually like, even though it seems like trivial from relative to all the work that's going on, is going to make the biggest difference in like the actual lives of like working developers. So very cool, man. Cool. Well, thank you so much for coming and sharing all this knowledge.
It's been fun.
If folks want to kind of like keep up with your work, follow all this stuff that you're doing. I mean, this is not even everything you're doing in that ecosystem.
Sure.
What should they do?
I mean, follow me on Twitter, EAF4. And when there's big stuff, I'll definitely tweet it out. I would like to make some screencasts about what we talked about, highlighting the cool features that are already there. Because it is totally a thing that apps can try and see and benefit from. I think it would be nice to do like a basic screencast of it. I would like to do that, tweet that out.
Very cool.
All the build work for Embroider is in the in the Embroider repo. So it's just like a Embroider build organization. It's called Embroider build. And it's a mono repo with a bunch of packages in it. But you can follow along what's going on there, file your bugs, try it out.
Awesome.
Yeah.
We'll be sure to link all that stuff in the show notes.
Awesome.
All right. Thanks again for your time, Ed.
Bye-bye.
Thanks everyone for listening, and we'll see you next week.